Hi guys, Miss Cochran here, and today we are looking at our new packet, Trigonometry Part 1. And in page 1, if you guys will look at that, it is going to start out reviewing Pythagorean's theorem. So, if you will, to find this letter x, that is our hypotenuse. If you notice, our hypotenuse is always across from the 90. So we would set this up 4 squared plus 8 squared equals x squared. 4 times 4 is 16. 8 times 8 is 64. When we add that together, I believe it's 80. Okay. And then when we take the square root, remember I've always taught you positive and negative. But we don't use a negative because you can't have a negative side of a triangle. So we're going to throw the negative one away and only keep and work with the positive answer. Now also notice it said simplest radical form. So when I get the square root 80, I need to break it down. So I would use 8 times 10. I know that 8 breaks into 2 times 2 times 2. And I know that 10 can break 2 times 5. You have 2 sets of 2's that get to come out. And a 2 times a 2 on the outside gives us 4 radical 5. And that is our answer for the letter x, is 4 radical 5. Now, if you'll look at number 2, the hypotenuse, if you notice, is the 24. So when you're making your equation, make sure you equaled it to the 24 because that's our hypotenuse. The other two numbers add. It doesn't really matter if you put the 22 in front of the x or the x in front of the 22. So that part, as long as they're added and squared, your math is good. Okay. So when you square 22, I believe it's 484. When you square 24, I think that's 576.
Wouldn't it mess your math up if you didn't square it first?
Yes. Yes, you do have to do the squaring before you can do the subtraction. Okay. Now, if you're using it in your calculator, though, and you typed the square, it would work. Do you understand my comment there? But if you wrote like 24 squared minus 22 squared, it would work. But if you just say 24 minus 22 and then do the squaring afterwards, it will mess up the problem. Okay? So I hope I'm making that clear. But I'm going to subtract that 484 off. When we subtract the 484 off, we should, I think, get a 1...
I got 92.
Oh, wait. Yes, it is 92. Yeah. So then we're going to take the square root of 92, and then I'll have to break that down. To break down that square root, 4 and 23 is good. And then 4 can break 2 and 2, and the 2's come out, and the 23 stays in, and that is our answer for the x, 2 radical 23. Questions on problem 1 or 2 using Pythagorean's theorem? Okay. All right, just make sure that the part that is the L is the part that you add, okay, those two sides. Now, if you will, let's talk about the 45, 45, 90 and the 30, 60, 90 for a moment. The 45, 45, 90 is a isosceles triangle where the two legs are the same number. And then whatever that leg is, the hypotenuse is that leg radical 2. So if you're using that formula and looking at number 3, see, I see a 10 as my leg, and I see it's a 45, 45, 90 triangle, which means the legs are the same. So if this is 10, then x is also 10. And y would be what? The leg times radical 2, wouldn't it? So it should be 10 times radical 2. This is your answer for that problem number 3. When you guys are looking at problem 4, there's multiple ways to work this problem. So I'm going to kind of scoot this over for a minute and show another way that I could work this problem. When you know it's a 45, 45, 90, and that means if two angles are equal, then the two sides are equal, and they gave you the hypotenuse. Well, if you know the two sides are equal, humor me a minute, I know it has x and y, but could we call them the same letter? Could I call them x and x because they're the same? Okay, if I happen to call them x and x, then I could do x squared plus x squared equals 16 squared. That would be 1x squared, and a 1x squared makes 2x squareds, and 16 squared is 256. If I divide by 2, I end up getting x squared equals 128. Excuse me. And if I take the square root of 128, we could break that down into 2 times 64, and then 64 can break 8 times 8. And the 8's come out, the 2 stays in, and we just found both legs. This is a method using the Pythagorean theorem to find that leg. So we found both of the legs are 8 radical 2. Now, that is one method of finding these two pieces, okay? But oftentimes, students use the formula that was given up here. We know that that hypotenuse 16 is sitting in the x radical 2 spot. Okay, that's the hypotenuse x radical 2. So our 16, if you will, we could have worked it a whole different way. We could have said 16 equals x radical 2 because that's the location of it on the formula. And then we could solve for the x using this equation by dividing by radical 2 on each side. When you divide by radical 2 on each side, the radical 2's on this side cancel, and then we have to rationalize our denominator. If you remember, we called it multiply by fancy 1. It's a fancy way to write 1. And I multiplied by radical 2 divided by radical 2. On the top, when I multiply, I get 16 radical 2. On our denominator, isn't radical 2 times radical 2 a radical 4? Which equals 2. And then can't we reduce our 16 and our 2? Right. So then we get the same answer as we had over here when we did Pythagorean's theorem. This would be the leg if 16 is our hypotenuse. Now, some students will see a pattern, okay? And I know this problem was not on your page, but do you guys see the pattern that if it's 16, isn't 8 half of 16? And then it put on a radical 2. Some students will see that if they give you a 45, 45, 90 triangle, and let's suppose the hypotenuse is 20, then the sides would be half it and stick on a radical 2. So you could say 10 radical 2 are the legs of that 45, 45, 90 triangle. Let's move back to our page. I'm just trying to give you some insight. I know it's been a long time since you guys have done these problems. So now let's look at number 5. Number 5 is also, I see a 45 and I see a 90, so I know my legs equal. And here's my hypotenuse, 14 radical 2. Well, hey, what are the legs? No, look again. If it's 14 radical 2, and look at our formula, they're 14s. Both legs are 14 because when you do this, it's the leg radical 2, and the leg is the 14. So 14 is our answer for both x and y in problem number 5. Now, if you guys will check, number 6 is now changing to a 30, 60, 90. Before I do the 30, 60, 90, I'd like to share a little bit about it, just kind of quickly, okay? It comes from a equilateral, equiangular triangle, okay, is where it comes from. And let's pretend this one had 20 on either side, on all the sides, because if it's equilateral, they're all the same. If the angles are all the same, the sides are all the same. Now, where does a 30, 60, 90 triangle come from? It actually takes this and it splits it in half. And that 60 that used to be at the top turns into 30 on either side. When you drop that 90 to split it, it actually cuts the 20 right here into two pieces, a 10 on either side. So then if you were wanting to do Pythagorean's theorem, you could actually solve for the x by using the 10 and the 20. If you do 20 squared is 400, 10 squared is 100. If we subtract our 100, we get 300. If I take the square root of 300, I would split this up into 30 times 10, and then I might break down the 30 into 3 times 10 and bring the 10 down. Now, I did a little bit of a shortcut here because my 10s come out and my 3 stays in. Now, if you happen to look at the formula, you'll see that it talks about the short leg. The short leg is always across from the 30. They call that the x. They double it for the hypotenuse. If you double 10, wouldn't you get 20? And the long leg is the short leg number times a radical 3. Well, 10 times radical 3 is 10 radical 3. So that's our numbers. We could now maybe look at the formula given. So the short leg, they refer to it as x. See how they're doubling the hypotenuse? But then the long leg is the x number times radical 3. So there's your little equation. And now if you'll look at number 6, what did they give us? What is the 8? 8 is the hypotenuse. So isn't it the double of the short leg? So the short leg would be 4. And then the long leg is the short leg number times the radical 3. So what would it be? That's correct, 4 radical 3. So I know it may have been a while since you guys did this, but I hope that made it a little easier, seeing how it just took an equilateral equiangular and split it in half. Now, let's check out number 7. And number 7 is actually a harder one, and I say that because they're giving you the answer to the long leg. And if you go back to the formula, isn't the long leg have an x radical 3? Okay, so the way I would solve this is I would say that 27 equals x radical 3. And I would solve this equation backwards. I cannot really, on number 7, do Pythagorean's theorem because I only have one piece. I only have one number, 27. I can't solve for the A and the C because we have too many things missing. So this is really one of the only ways to work that using that formula. If we would divide by our radical 3, and then rationalize the denominator by multiplying by radical 3 over radical 3, the fancy 1. On top, you're going to get 27 radical 3. On bottom, isn't that 3 times 3 a radical 9? Which turns into what? What is a radical 9? The square root of 9 is 3. And then our 27 and our 3 can reduce to give us 9 radical 3. Now, a pattern is in here. I don't know if you're seeing it, but didn't it just divide by the 3 and put on a radical 3? Oh, so that is our short leg, which happens to be, in this problem, the y. So it's 9 radical 3. Now, if you look at the x, the hypotenuse, didn't it say we just double the x? We double short leg for the hypotenuse. Well, let's double a 9 radical 3. Double is like multiplying it by 2.
18 radicals.
It would just be 18 radical 3. And that would be your x value, the hypotenuse of that problem. And if you will look at problem 8, and if you look at your numbers, is that short leg or long leg they gave? It's our short leg because it's across from the 30. So in order to get the hypotenuse, I need to double this number. Well, what's 2 times a 5 radical 6? Okay, so this one's 10 radical 6. Okay. And the y, don't we take the short leg and we times it by a radical 3? Okay, well, that means we're going to take our 5 radical 6 and times by a radical 3. Well, wouldn't that be 5 radical 18? I think we can simplify that down. I know that 18 breaks into 9 and 2, and doesn't 9 break into a 3 times 3? So 3's are going to come out, and they're going to join the 5 on the outside. So it's going to turn into a 15 on the outside, and what's inside? A 2. Yeah, that little 2 is still left. So 15 radical 2 is your y answer, the long leg answer for that problem. Now, we will continue to practice 45, 45, 90, and 30, 60, 90, as well as seeing Pythagorean's theorem. But that's our review of it for today. You'll see some of it in our practice in our homework assignment. But let's move to page 2. Okay. In page 2, they talk about a trigonometric function is a function whose rule is defined by a trig ratio. Well, what's a trig ratio? It compares the lengths of 2 sides of the triangle. So it may be like hypotenuse over short leg, or it might be short leg over long leg. It's comparing 2 lengths of the sides of the triangle. Okay. They often use the Greek letter theta that looks like an O with a line crossed through the middle. It's used to talk about the angles, okay? And they wrote it in here. It's not real bright, but this is our theta, okay? It has the O with the little line through it. And different geometry teachers teach the trig ratios differently. Sometimes you'll hear Sakatoa. I was never a very great speller, so that one didn't work well for me. My teacher taught the mnemonic Tom's old aunt sat on her cat and hollered. That's the one that my teacher taught us in high school, was Tom's old aunt sat on her cat and hollered. Now, there's many mnemonic devices that you guys can use. Some of you may have heard something with a hippie. Some say, see one hippie, catch another hippie, tripping on acid. I like to say no to drugs, so I do tripping over apples. But, all right, so let's continue our little discussion. What does it mean when I do sign C1 hippie? It means the opposite leg over the hypotenuse. Now, guys, I know it's not really dark, so I'm going to kind of write mine in. There's A, there's B, and there's C. If you're looking from angle theta here, opposite would be letter A. So I'm going to go ahead and put opposite right there. If you're if you look at your letters, the 90's here, so the C is the hypotenuse, and that only leaves one other piece, so it must be our adjacent leg. Now, the adjacent leg, just to kind of do a little clarification, this little line here and the hypotenuse line, they are both adjacent to that angle. They both touch that angle. But then why do we not call the C the adjacent? Because it has a better name. The hypotenuse says more information about the C. So, but they both really, B and C, are adjacent legs of that angle. But C has just a better name. Does that make sense? I hope so. Now, so if we're writing using this triangle, the ratio of sine would really be A over C if you're using your triangle. And if we're using the triangle for cosine of theta, it would be the adjacent over the hypotenuse, so B over C. And tangent is opposite over adjacent, so it's A over B if we're utilizing our triangle. And that's what you guys will do later on in our math. Only the triangles may have numbers, and you'll use the numbers that are given. Now, today's lesson, they're going to teach you about reciprocal functions. And reciprocal functions, there are three: cosecant, secant, and cotangent. I like to start with cotangent because it sounds like the word tangent. They have kind of root words that are the same. So tangent and cotangent are reciprocal functions. And what that means is to find cotangent of theta, it will actually take, and instead of doing opposite over adjacent, it's going to do the adjacent over the opposite. Or in that triangle over here, it would do B over A. And remember, reciprocals just kind of flip-flop. Another way to write cotangent is 1 over tangent. Look at your secant. Secant is actually cosine's reciprocal, so be careful. It's going to take the adjacent over hypotenuse and flip it over, so it will be hypotenuse over adjacent. Or in our little triangle, it's the C over the B. And the cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, it is hypotenuse over the opposite. In our triangle, instead of A over C, it would be C over A. And these are the three reciprocal functions. Now, I like to help students try to learn which ones are paired together. And it's easy to pair tangent with cotangent. But these you may have to be careful with. I like to say it's an S with a C and a C with an S. You never do CC and you never do SS. It's always a C with an S and an S with a C. So that may help you. Sine goes with cosecant and cosine goes with secant. Now, we're going to look at problem number 9. And using this problem, we're going to solve all 6 trig ratios. We're going to set up all 6 trig ratios. There is a little problem, though. I don't see hypotenuse. So what can I do? What math could I do to the Pythagorean theorem? I can do, the 16 squared plus 30 squared equals, we can call it, I guess, C squared. This is the first thing that we would have to do so we know what that side is for the hypotenuse. Okay, because that is what, 256 plus 900, so 1156 is correct. And then take the square root. Remember, we're not going to use the negative answer. I believe it is 34. Okay, so 34 is our answer for that side, for that hypotenuse. Now we're ready to set up our ratios. So sine, remember, is opposite over hypotenuse. And, okay, well, do I know which one is opposite? Okay, find the angle. Where's theta? And run across from theta.
16.
Okay, 16 would be my opposite.
Over 34.
Okay, hypotenuse is our 34. And that means adjacent must be the 30 if I'm using this theta down here. Are you guys okay with that? Okay, so we said it was 16 over 34. Okay, but they like to reduce. So 2 can go into both of those numbers, right? Okay, so 8 over 17 would be the final answer for that one. Now let's do cosine. And cosine, if you recall, was your adjacent over your hypotenuse. Okay, so our adjacent would be 30 over 34. And we can reduce that one also by 2. When you guys reduce that one, you end up with 15 over 17.
It's good too.
Thank you so much. It looks perfect.
It does. It's really good.
I'm proud of you guys. Now, your tangent is your opposite over adjacent. So if you look at our little triangle, our opposite is 16, but our adjacent is 30. And reduce it, and it'll reduce down to 8 over 15. Now, to me, the fun part is now that you know these 3 answers, to get the reciprocals, all you do is flip it over. Remember, tangent goes with cotangent, so they paired those for you. C with an S, so cosine is paired with secant, which is correct. And then sine is paired with cosecant, which is also correct. So they already paired them. All you have to do is flip it over. So this answer for your cosecant is 17 over 8. For secant, it's 17 over 15. And for cotangent, it is 15 over 8. And that's our answers for problem number 9. Okay. Now, when you guys get into problem 10, if you happen to get a, I may need to get it started because they didn't draw you the picture, did they? They do give you a bit of information. We need to really look at what they gave. Didn't catch another hippie. Guys, they gave you the adjacent and they gave you the hypotenuse of a triangle. So let's draw a triangle. Now, hypotenuse, we know where it goes. Well, we've got to decide where the angle is going to go. If you guys like the angle in that bottom corner, we can put the angle there. And that means that the adjacent would be beneath it. Okay? So, in order to do this problem, you're going to have to find that side. Am I making this make sense? And if it's a radical, you may have to simplify radicals when you do your problem. Now, I'm going to let you guys think about this one, and it's to be continued, okay? We'll look at it more tomorrow. But today, I want us to look at these bottom problems, okay? They're going to get you guys to use these 2 formulas and find exact values of sine of 45 or sine of 30 or tangent of 60. We're going to use these triangles and find exact answers. Just using these formulas that have no triangle really, X is the side. Okay, it's just the formula. Now, it's kind of cool to see this. In sine of 45, you're going to use one of these 45s. It does not really matter which 45 you use. I would say just kind of look at one of them and go from there. Sine, is opposite over hypotenuse. So, opposite of that 45 is x. And then hypotenuse is x radical 2. But you guys have to simplify this problem, okay? And we can't leave a radical on the denominator, so we would rationalize the denominator by multiplying by a radical 2 over radical 2. I don't have a lot of space here. On top, you're going to get an x radical 2. On bottom, you're going to get a... it's going to be a radical 4, but that turns into 2x. And your x over x cancels, leaving you just a radical 2 over 2 for that first answer. So sine of 45 reduces to radical 2 over 2. I wish they'd made the squares just a tiny bit larger. Now, if you're looking at sine 30, well, that's using down here. And if I do sine 30, that means opposite the 30 is x. And it's opposite over hypotenuse, right? And hypotenuse is 2x. Well, if we reduce the x's, isn't that really an understood 1 on top? So you end up with 1/2 as the answer to that one. So sine of 30 is really equal to 1/2. Let's do sine 60. Well, that means we're looking from the 60, which means opposite would be x radical 3. And hypotenuse would be 2x. Now my x's can cancel, because an x divided by an x cancels out. And then we're left with radical 3 over 2, the answer, the exact solution to sine 60 degrees. If you're doing cosine, remember it's your adjacent over hypotenuse. So now we're going to do the adjacent over the hypotenuse, which is x over x radical 2. Isn't that the same answer though? So in this problem, I don't really have to do it again, do I? We just simplified that same problem by rationalizing it. It's going to reduce to a radical 2 over 2. This is your answer for cosine 45. Now cosine 30, we may have to do some math here. So cosine 30, remember it's the adjacent of the 30. Well, adjacent is the x radical 3. It's the adjacent over hypotenuse, which is 2x. X over x cancels out, leaving you a radical 3 over a 2. And that's your answer for cosine of 30. Cosine 60, well, okay, we're going to have to do the adjacent of the 60. Okay, so be careful. We're looking from the 60, so that's opposite. This would be adjacent, which is x. It's the adjacent over the hypotenuse, and the hypotenuse is 2x. If we cancel and reduce x over x, it really leaves us 1/2, because there is that understood 1 in front of x. Guys, your assignment is to try to complete pages 1 through 4. Page 3 and 4 have like the 30, 60, 90, Pythagorean's theorem, writing ratios. Some of page 3 is going to be very, very quick because you're just writing the ratios. Okay, especially when you get into page 4. So good luck, and let me know if you have problems, and we'll talk about this more tomorrow.